teaching series. Today we have a very simple problem here in chemistry. So use the spdf notation to write the electronic configuration of the following: potassium, aluminium, chromium, and copper. Use the spdf notation. Solution. Now, by spdf notation, we know we have the orbitals. The orbitals are regions in an atom where electrons are actually located. And we have the s orbital, the p orbital, the d orbital, and the f orbital. I would just immediately like us to understand that using the spdf notation, we should have an understanding that the s orbital carries maximum of 2 electrons, the p orbital carries maximum of 6 electrons, the d orbital 10 electrons, and the f orbital 14 electrons. Having that in mind, let us go to write the electronic configuration. In writing the electronic configuration, let me just teach us a method. We have 1x, we have 2x, 3x, 4x, 5x. We have 2p, 3p, 4p, and 5p. We have 3d, 4d, and R5d. As at your level now, O level, we should limit it to the d orbital. So here it goes. This is how it goes. We have it like this, like this, like this, like this, and like this. So this is the lowest energy level, the 1x. So we start with the 1x. We have 1x, we have 2x, we have 2p. After 2p, we have 3x. After the 3x, we have 3p. After 3p, we have 4x, followed by 3d, and we have 5x. At the level of 3d now, we should stop. Now, to write the electronic configuration of potassium using the spdf notation, from what we have now, the atomic number of potassium is 19. Now, potassium has atomic number of 19, so writing the electronic configuration number 1 for potassium with atomic number of 19, I will have it as 1x. Remember, s can carry maximum of 2 electrons, so I have 1x2. The next is the 2p. The 2x. S carry maximum of 2 electrons, so I have 2x2. The next is 2p. P carry maximum of 6 electrons. As you are doing this, you are counting. We have 10 now. After the 2p, you have 3x. X carry maximum of 2 electrons, so I have 2. Followed by the 3p, I have my 3p. Now, if you count it here, we have 2 plus 2, 4. Plus 6, we have 10. And 2, we have 12. And the atomic number is 19, so we still have about 7. So P carry maximum of 6 electrons. So what I have here is what? 2, 4, 10. I have 10 here. Plus this. 18. What I have here now is 18. Remaining 1. The 1 goes to the next orbital level. After 3p, we have 4x. So I have 4x1. Now, if you take a look at it, this is potassium. Now, from what we have here now, we can get the group and period to which potassium belongs. Now, take a look at it. The highest coefficient here in the numbering is 4. So you find out that potassium belongs to period 4 of the periodic table. Period 4 of the periodic table. And the superscript to the highest coefficient is 1. So potassium belongs to group 1 of the periodic table. Number 2. The second one there is aluminium. Aluminium, number 2. Aluminium has atomic number of 13. Atomic number of aluminium is 13. So here we go again. 1x2, 2x2. The next is 2p6. You count. This is 10. Remaining 3. The next is the x. We have 3x2. Remaining 1. The 1 goes to the next higher energy level, which is the 3p. So we have 3p1. And if you take a look at it also, you count. 2 plus 2, 4, plus 6, 10, 12, and 13. So aluminium, the highest coefficient here is 3. So aluminium belongs to period period 3 of the periodic table. Period 3. Period 3 of the periodic table. But here now, to get the group, the highest coefficient occurs twice. So what do? We add their superscript. When you add the superscript together, you find out that aluminium also belongs to group 3 of the periodic table. And the next one there is chromium. Chromium is a transition metal with atomic number of 24. Chromium. So number 3, chromium. Chromium has atomic number of 24. It's a transition metal, and we know that the transition metals, they are a special group of metals lying between group 2 and group 3 of the periodic table. So writing the electronic configuration, 1s2, 2s2, 2p6, 3x2, we have 3p6, 4x2, and we have 3d4. What I have here is chromium. Please understand that chromium can easily be written like something like this. From here down to this point here is argon. So I can write my chromium. Chromium can also be written as argon. Those of you writing jam, so you see something like this, argon, which is the electronic configuration of this one that is in that rectangle. Then we have 4x2 and we have 3d4. Please understand that chromium is a transition metal, and you can see that it has incompletely filled J orbital. And number 5, copper. Number 4, copper. Copper is also a transition element with atomic number 29, written as 1x2, 2x2, 2p6, we have 3x2, 3p6, 4x2, and we have 3d9. If you look at it also, from here down to this point here is argon. So copper can also be written as argon, and we have 4x2 and 3d9, especially for those of you writing jam. Now these two elements, they show what we call singly filled stability and completely filled stability. I will show you that in our next video. Thank you very much. Go through what you have there, marry with whatever you have in your textbook. Keep studying, keep studying. If you have any problem, just drop there in the comment section and you'll be tended to. Thank you very much and bye.